Today, we're going to explore one of the most common, yet super sneaky ways your entire online world can get flipped upside down in, well, a heartbeat.
So let me ask you a question. Can you get hacked just by clicking a link? I mean, it sounds like something out of a movie, right? Well, the answer is a big, scary yes. And we're about to see exactly how one single innocent-looking click can lead to a total account takeover.
So, how does this actually go down? It's honestly kind of shocking how simple it is. First, an attacker cooks up a special link. It looks normal, but it's hiding some nasty code. You get the link, maybe in an email, you click it, and you land on a website you totally trust. But here's the trick. That link just secretly injected a tiny piece of code into the site, and that code immediately grabs your session cookie. That's the little thing that keeps you logged in so you don't have to type your password every 5 seconds. Well, once the attacker has that cookie, they can just pop it into their own browser. And boom, they're in. They're logged in as you.
I love how cybersecurity educator Loui Liang Yang puts it. He just says, once they have that session, that's it. Game over. Your account is theirs. And the craziest part, they never even needed your password.
Okay, so this powerful and very common vulnerability, it actually has a name. It's called cross-site scripting, or XSS for short. Let's really break down what that is.
So, at its heart, cross-site scripting is all about an attacker finding a way to sneak their own code onto a website you trust. And when you visit that website, your browser has no clue that the code isn't supposed to be there, so it just runs it.
Here's a really good way to picture this. Imagine a website is a cookbook full of recipes you trust. And your browser, it's the chef. The chef's job is just to follow whatever recipes are in the book. Well, an XSS attack is like an attacker slipping their own malicious recipe into that cookbook. The chef, your browser, just sees the instructions and follows them, no questions asked, without ever realizing they've been tricked into making something terrible.
So let's make this super clear with an example. A website has a comment box, right? It's expecting someone to type in their name, something normal like Carlos Montoya.
But an attacker, they don't give it a name, they give it code. They type in a little snippet of JavaScript wrapped in these script tags. If the website is vulnerable, it doesn't check, it just saves it. And then next time anyone loads that page, their browser sees those script tags and says, oh, code to run, and it just executes whatever's inside.
And what's really interesting is that there are two main flavors of this attack. On the left, you've got what's called reflected XSS. That's the one we talked about with the malicious link. It's kind of like a one-time attack that bounces off the server and hits one specific user. But on the right, well, that's stored XSS, and it's way scarier. This is where the hacker's code is actually saved on the website itself, like in a comment or on someone's profile page. Now, it's not a one-time thing. Every single person who visits that page gets hit by the attack.
So let's say a hacker pulls this off. The script is running. What can they actually do? What's the real damage here?
It's a lot. They can pop up a fake login box that looks totally real to snatch your password. They can hijack your session, like we saw. They can secretly send you to a phishing website. Or, and this is the wild one, they can actually take control of your browser, at least for as long as you're on that hacked website.
So how does that hijacking even work? Well, there are tools for this, like the Browser Exploitation Framework, or BEEF for short. An attacker plants what's called a hook script on a vulnerable page. When you visit that page, your browser runs the script and gets hooked, kind of like a fish. It then secretly calls home to the attacker's server. Now the attacker has a dashboard where they can literally send commands to your browser, like, hey, show this person a fake Facebook password prompt right now. It's crazy.
Okay, so this isn't just stuff that happens in theory. These kinds of bugs are found in huge companies all the time by ethical hackers. So let's check out a couple of real-world examples.
First up, GitLab. In this case, a hacker found a vulnerability in a place you would never, ever think to look, a user's profile name.
And what's so cool is you can see the whole story unfold. The hacker reports the bug. At first, GitLab says, we block script tags, so it's not a huge deal. But the hacker doesn't give up. They show exactly how you could use even just a simple link tag to create a really convincing phishing attack. And that got GitLab's attention. They took another look, and about a month later, they shipped a fix.
This was the core of the hacker's argument. They pointed out, look, if you let me turn my username into a clickable link, I can send people anywhere. I can abuse the trust they have in your website to trick them.
And here you can see that professional pushback from the GitLab security team.
It really shows how in this world hackers have to prove the impact. It's not enough to say something does not look great. You have to show exactly how it can be exploited. And because this hacker did that, they got the bug fixed.
All right, our next case study takes things a step further. This one involves the cybersecurity company Acronis and an attack delivered through one of the most trusted channels there is, a welcome email from the company itself.
So, a hacker figured out they could put malicious HTML into the first name field when they signed up for an account. Then, when the automated system sent out the welcome email, they would include that bad code. And as the hacker pointed out, this is so dangerous because, well, when a suspicious link or message comes from an official company email address, it just feels legitimate. Your guard is down.
Okay, so we've looked at the tech, we've looked at real-world bug reports. Let's bring it all back home. Why does any of this actually matter to you? Look, at the end of the day, XSS isn't some abstract problem for programmers. It means your passwords can get stolen. It means your social media, your email, maybe even your bank account can get taken over. But the most important thing to remember is that this attack works by turning your own trust against you. It's dangerous because it happens on websites that you think are safe.
And that kind of leaves us with this one big final question, doesn't it? The entire web is built on a foundation of trust. We trust that when we go to a website, it's safe. But cross-site scripting shows just how fragile that trust can be and how it can all be broken by just one single line of code. It's a pretty powerful reminder that staying safe online is something we all have to think about.